Hello, this is Ashita Patel, and this is my Physics 2211 Lab 4 Oscillations lab report. So before beginning the experiment, there were a few equations that were needed to be understood. The first being Newton's second law, F net equals dp over dt. The force of gravity, which is F grav equals mass times gravity, where gravity is equal to 9.8 meters per second squared. The force of the spring, where F spring is equal to negative k times L minus L naught times L hat. And net force, where F net is equal to F grav plus F spring. And finally, it was important to understand the energy principle with these equations listed below. So in this experiment, I used the video provided and uploaded it into Tracker to find the X and Y position data that is collected and then put into a CSV file. I tracked the movement of the object hanging on the spring to find these data points. I then used the GlowScript code to create the computational model and inserted the CSV file from the previous step. From there, I compared the predicted motion and observed motion of mass in both x and y directions and observed the energy changes in the model. So this is the tracker video. I tracked the movement of the object hanging from the spring and uploaded the tracked values into a CSV file to upload into my GlowScript code. And here is the GlowScript code. I changed the mass here to 0.402 kilograms and changed the position and velocity accordingly from the video. I then also set the constants g to 9.8 and found the spring constant to be 6.83 and the relaxed length of the spring to be 0.123. And here are the equations for L, L hat, and S. I also included the equations for kinetic energy, gravitational potential energy, spring potential energy, and total energy. So this is the loop created. I also set the time to the length of the video. I inputted the needed formulas for F grav, F spring, and F net, which were defined in the lab preview. I also updated the object's velocity and position as well as the spring. Additionally, updated the energy calculations from the equations listed before and included delta K, delta US, delta UG, and delta E by subtracting their respective final and initial values. After putting in the CSV file, these were the three graphs produced. This first graph is an energy versus time graph that showcases delta K, delta U grav, delta U spring, and delta E. And here is the X position versus time graph and Y position versus time graph that shows both the experimental data and the data from the model. So what does this mean? Is the energy principle satisfied? I said that it was not satisfied because, as seen in the last graph, delta E doesn't remain constant, and this is a source of error in the experiment. Additionally, using the data I obtained in Tracker, these were the two periods of oscillation for both the X position and the Y position data. They are different due to possible errors while tracking the video to collect the data. Thank you.